Hi, everyone. My name is Elaine Tanimura. I work at PamTen. Today's event is being hosted by PamTen and SheTech. Just a few housekeeping things. Everyone, it will be on mute and your cameras are turned off. You could use the QA box to post any questions that you have. We will be recording this session and the webinar will be posted and shared with you after the event. So PamTen is an IT staffing and solutions company with offices in Canada, the United States, and India. We offer a broad range of services for all of your technology needs. Our services include IT staffing, strategic advisory services, custom IT solutions, cybersecurity services, and product development. SheTech is a nonprofit, and our mission is to develop a pipeline of qualified women to fill critical IT roles. SheTech introduces technology to girls at a young age, mentors women through college, and matches them with organizations to meet their IT expertise. So you can check out PamTen and SheTech on the web. Now I'd like to introduce or turn this over to Sujal, who will lead our discussion. Thank you.
Thank you, Elaine. Good morning, good afternoon, good evening, everyone. Hope you all are doing well and staying safe. My name is Sujal Nair. I am a long-termer in the IT industry, have got experience of around 16 years into various areas related to managed services, AI, cloud, and digital automation. And we have our presenter and host today, that is Dr. Chitra Dorai. Chitra, you would like to get your introduction so that everybody knows about you, because again, she has an extensive experience into AI and data science, and she has a lot of patents under her belt. So Chitra, over to you.
Sure. Thank you, Sujal and Elaine, for inviting me to this webinar. Glad to be here. So good day, everyone. So I am an AI scientist by formal training, and I spent 20 plus years at IBM Research and other parts of IBM working on all things data. So 30 plus years of client engagements and large scale projects, leading and designing and creating solutions, industry transforming solutions in many industries, financial services to healthcare to media and entertainment. So lots and lots of data science and AI experience. So currently, I left IBM to start to found a company called Amicus Brain Innovations, and Amicus Brain's mission is to change the caregiving tasks for people who are caring for their loved ones with neurodegenerative disorders. So we are changing the burden. We are reducing the burden of caregiving through the use of AI.
Okay, thanks, Chitra. And I think, it would be the next slide. That's where your complete introduction is. And a lot of work that Chitra has done, it's really hard to put that forward in just one slide, right? And maybe in just 10 to 20 seconds. However, as we get into more discussion around what we have in today's agenda, would add a lot of value to understand how, AI is making a difference in the overall world and how it can add value to your career and how you can, move forward in the endeavor towards exploring opportunities with AI. So let's move to the next slide. Okay, so digital transformation is a key area, or the vast area that gets into the digital era that we are today. And it's in and around three key pillars, which is data analytics, data science, and cloud. So our key role or key discussion today would be in and around the one of the pillars, which is data science, and the AI technologies that actually is surrounded by data science and various other cloud technologies, which are kind of embedded together. And we can also say that they are kind of auxiliary because they are so dependent on each other that one cannot stay without another one, right? So let's move to the next slide. Okay, so let's quickly talk about the current landscape of job that we see, or what we have researched from the various input and the various partners that are available in the market, like starting from Gartner to World Economic Forum. The key or emerging roles that we have in the industry today are the top 10 are in and around data, AI, cloud, and software development. And all these software development or application development piece that we talk about is in some way or the other are related to cloud. And that again, falls down to data analytics, AI, and various other pieces, because anything that we pick today in the market, like if you need to run something like marketing, it's vastly related and embedded with data analytics, and a lot of recommendation and stuff are used or made through artificial intelligence and machine learning algorithms. So if you go to Facebook, you go to Netflix, what you watch, what you buy, what you search, it's all embedded together, ties up, and tailored together to your need. It looks like your need, however, but that's how it is, and they are all tied together with the one of the key pillar that we are talking about today is data science, which again relates back to AI and data analytics. And there are a lot of declining jobs that are, the standard. It has been like that for the last 5 years. Any monotonous jobs that we have been seeing or that we have been hearing about over time, that is kind of getting less demand, and we are getting more and more next generation technologies that are going to be in demand for next couple of years. Let's move to the next slide. Okay, so the key is around data science, and I will probably ask a direct question to Chitra, that how and what exactly is the data science in a layman language, so that all of us can understand, because there are a lot of use cases, there are a lot of areas today that we use, as Chitra already highlighted. She has worked in healthcare, she has worked in various other industries like banking and stuff. So how does data science and AI come together and assist us in the overall industry?
So data science has actually evolved right in front of my eyes, given I've been in this for now 30 years. So what used to be data engineering, right? One of developing techniques to collect, clean, and massage them, visualize them, and make sense out of it, has actually now grown into a proper science discipline, becoming a part of a core curriculum in computer science and information technology programs, right from undergrad through your master's degree and all the way through PhD. And because from engineering, it has moved on to science, because certain principles have come into place and have become codified as the core principal concepts of extracting what is called actionable insights from raw data. So essentially, data science is a field that teaches us how to I actually would say examine data, look at data, colloquially put, collect. So it starts with the collection of data and curating the data. Data curation is emerging as an important aspect of data science, wherein you ascertain the provenance of data. Who is giving you the data? Where are you getting the data from? How biased is the data? And so what's the metadata about the data, being what is the descriptive information we can find and validate about the data? So data curation is an important aspect. And from data curation, having curated the data, what is the analysis we can do, right from simple statistical analysis that tells us what is in the data to doing more predictive analytics. So you are essentially think of data science as a pipeline of processing that goes on data. And the data can be numerical data, or it could be text. Think about agents in contact centers writing logs after the phone calls, and it could be audio video recordings. Again, think of audio recordings that happen when we call a financial services company. So data can be very multidimensional and also multivariate. So that is you think of data science as a pipeline of increasingly extracting insights from the previous stage in order to act upon. Ultimately, the insights need to be actionable. It's one thing to visualize the insights as pie charts and bar graphs and heat maps and so on. At the end of the day, the question is, how are you going to use the insight? So therefore, there is quite a bit of emphasis on this actionable insights. So that's what data science at its core is all about. So data curation, data management, and then data analysis, data visualization, all these are aspects of data science. So we can look at data. There are different functions that you do on data, and this page that we are looking at is actually categorizing the kinds of techniques that we would apply to different kinds of data. And that both the analysis is contextual based on what kind of data we are working with, as well as it is the domain focused, meaning what insights would make sense. Suppose I were analyzing X-ray mammograms, for example, then the insight should lead to which are cancerous areas and which are benign lumps found in the mammograms, as opposed to a generic insight about how the image is looking healthy and so on. So the insight is both contextual and it is dependent on the variety of data that you have for analysis.
Thank you, Chitra, for the great insight. So Elaine, let's move to the next slide. So as Chitra pointed out, the process of data science would be more about capturing the data. That's the key, because if you don't have data, there's no way that you can do the rest of the processes. So the capturing is the key, wherein, as I gave the example of Netflix and Facebook, that's what they do. They look at your keyboard activities, your searches, your cookies on your system, and they capture that information. They maintain it in their in their databases. The metadata is mined, and then they process it, and then they start communicating it with two parts. One is analysis, which is they give you the graphs, they give you the recommendations. They also, like if you go to Amazon, you get the analytics that, okay, you're looking at a product in last 30 days, this is the pricing trend for it. So today is the right day to buy it. It's the best deal for you. So those kind of analysis also something that is thrown out through the data analytics, and also the clicks and the searches that you do through internet. So this is one area, like in the previous slide we were discussing, right? So fraud analytics, KYC frauds, all these are kind of frauds that are actually protected today. It falls under the piece of cybersecurity. However, the back end is still about artificial intelligence and data science that actually brings in those intelligent alarms that blows up when you are trying to access, or somebody else is trying to access your data or your account from a different location based on your locale information, or maybe entering your wrong password due to some reason, and then you start getting emails. I will give an example that happened with me yesterday. Yesterday night, I was about to sleep, and I get an email stating that my Spotify account has been accessed in a different part of the world. So now my question is, who was that? So I'm getting an email, I can either say that it was me, or else I can also go ahead and decline, and automatically it gives me an option to reset my password. So that is a kind of intelligence that gets into picture when you bring in data science and AI together on a platform, which is probably Spotify is not a great platform that we can talk about, because apart from your email and maybe some payment information and your playlist, there's no much there. But still, that's one of the area that people are still trying to access, right? So your private data is not private anymore. So that's where AI and data science get into picture for cybersecurity. Likewise for banking, right? Like, what is the kind of recommendation that is made? What is the kind of stock you should look for? So that are also something that are in today's date are recommended through AI and machine learning. Let's move to the next slide. This majorly talks about the industry, and it's far and vast. Probably it covers everything: manufacturing, healthcare, retail. Retail is a couple of examples I gave. I spoke about banking, education. Like if you're looking to go into tools like Google Learning or Coursera, all those, you on the basis of your searches, your last internet search, you can give recommendation. Like if you look for, say, once you look for Microsoft certification, next time onwards, all the advertisement that you get on YouTube or Facebook would be related to that, right? So that's the level of data mining that happens from an AI machine learning perspective. And automotive industry is a key, because we all know Tesla, we know all the new brands that are coming in with electric cars and semi or completely autonomous driving. All of them are part of AI, machine learning, and data mining pieces. So let's move to the next slide. And
May I add here, if we can stay on that one for a bit.
Sure. Yeah.
So what you're seeing is this accelerating trend of recognition that data is a fundamental asset to any company in any part of the world. I think that is one of the foremost insights and trends that have come out of the past decade, I would say 2011 through, and it is continuing. So with that recognition dawning on every company, small to medium to big, so every company has recognized that they are sitting on this treasure trove of raw data, almost like a natural resource like oil. And just like oil changed the industrial revolution, changed the nature of the world through industrial revolution, how can insights from this natural information resource data how can data be harnessed to change the way we live, we work, right? We travel every sphere of our life. And that's what I have seen. So AI and data science being embedded in as an integral department or a function in every company that can afford to establish a company. If they cannot now, there is a whole trend of software as a service that one can also work with companies that. And in addition to these industries that you're seeing, you can very easily think of, right? Every time you see a recommendation system, every time there is an anomaly detection, in your transaction, all those are examples of data science at work. In addition to these industries, what I also observed, and I worked actually close to 3 years, is the back office operations, one you don't hear. Think about your finance and administration. Think about your talent, HR, right? Human resource, talent management. Think about your procurement. So these are all core operations in any company that's alive today. And even those, what we did was we looked at the entire process of procurement, entire process of think about HR, from sourcing the candidate, then matching the candidate with the job description, then analyzing the candidate's fit, not only through technical profile, but other aspects. So every part of, and then retention, performance management. So every function, every process involved in HR also is being embedded with some level of data-driven insights in order to ensure that the employee experience is elevated and the core metrics, whatever the metrics are, whether it is retention or whether resume to higher conversion rates, they are all maximized. So in fact, I coined the term reimagining operations, reimagining with AI. People have been talking about transforming operations in any part, whether it's sales or marketing or supply chain or procurement or education. But for me, transformation still fell short in terms of proper use of AI. Why? AI for the first time allows you to rethink the way things are getting done. You no longer have to think that whether this task is still done by humans, but how do we do it more efficiently and with less error, right? But now AI can operate work on behalf of the human beings, and therefore tasks that were done by human beings can actually be now carried out to the most part by humans. So now that allows us the freedom to reimagine the way that we have been doing things. So it became a very popular word, reimagining with AI. And in fact, IBM ran a whole Think conference with that as the slogan, because AI became the face of IBM when I was there. So all that is to go to make this point about everywhere you look around, whether we notice or not, it's becoming part and parcel of our experience. Over to you, Sujal.
Thanks, Chitra. And likewise, as we are talking about opportunities or career opportunities, right? So AI plays a lot of importance, not just for the career in AI, but otherwise. Like if you're searching for a job and you're applying for a job in LinkedIn, half of the time you do not even see an update that your profile has been viewed by the recruiter. The reason is you do not meet you don't fall through the funnel which is there, which is monitored by an AI system. So if your CV, your profile or your resume is not going to the other side, so nobody looks at it. So using the right keywords, using the right roles and responsibilities related to the job is the only way your CVs also will get recognized. And that's, you can blame AI for that, but it's what it is. So if you have 100 CVs, it's not like for a recruiter today, it's not like in 1990s or 2000s that they have to go through all 100 profiles and the top 10 wins. It's more like you will only get 10 out of it, which actually matches. So the chances of the wrong profile getting onto the table is very limited. That's how it goes. So let's go to the next slide.
Okay, so we talked quite a bit about data science, and then you also heard us drop AI here and there, right? What is the connection? Are they interchangeable? Can I just, use AI in place of data science? So no, is the simple answer. So data science is all about data in particular, right? That you have this information resource, information asset called data, which comes in in variety. It comes in at different speeds at us, the velocity as well as the veracity. The truthfulness of the data also matters. Suppose I were to analyze how my customers are viewing my company, and if I go collect data out of the social media, I need to be cognizant of how truthful those reviews are. Right, as you know very well, trolling is a part of the social media experience, and therefore not all reviews, first of all, were probably generated, written by humans. It could be AI written too. So the veracity also plays a role, right? So often you will come across this 3 V's, variety, velocity, and veracity. But that's all to do with data. AI goes for, much more than that as a science discipline, as part of computer science. So when you look at AI, there are 3 things that that becomes part of what's encompassed by this discipline, right? One is the machine learning. That's where the data science connection is the strongest, right? So machine learning is part of AI, and it is all about statistical analysis of the data, right? And it's looking for predictions, what we are finding in the data, what we are looking for, and discovery. So think about, I spent close to 10 years helping the US homeowners to avoid foreclosure during the 2008, the big economic crisis. In fact, it was a housing crisis all around the globe, especially in the US, housing being one of the key pillars of the US economy. So for 10 years, every day I got up and studied the human behavior underlying typical homeowner and what drives them to pay their monthly payments, and what prevents them, what are hindrances to making their payments, and what is their interest and intent towards their home ownership, etc. Because all that went into understanding human behavior, the US homeowner behavior, so that we can save them from foreclosure. At that time, when I was looking at the data, several million US homeowners were delinquent in their payments, 90 days or more, and were facing the risk of eviction, what is called foreclosure. So when you look at that kind of a data, now we need to every day figure out, if you're a company serving the US homeowners, collecting their payments, it's called mortgage servicing. The banks make the loans to buy a home. Bank makes loan to me, to you, to buy our homes. And then our loans are then passed on to another third party called mortgage services, who actually work on our loans every month. They collect payments from us, they give us tax statements, and then if we become delinquent, they work with us to keep us at home, right? So I was closely working with that. I was a trusted advisor to Fannie Mae, one of the government agencies in the US, to keep US homeowners in their homes and avoid foreclosure. When I was looking at the data every day, let's say we were processing 500,000 US homeowner loans. Every day there were 25% delinquency. We need to make a prediction about, given today is the 11th of May and 15th being the deadline to make your mortgage payment, who is likely to pay or not pay, and what is driving their non-payment behavior. That is prediction, right? Given my behavior, past behavior, how I'm going to, what is happening in my life. So in order to whether I'm going to continue to make the payment or not. So those are what we call predictive analytics, where you're looking at the data, the past behaviors of not just Chitra, of course, Chitra-like people, and making sense of what is likely to happen, because what is that prediction is going to drive our contact center operations, whether Chitra needs to be called today in order to make sure that she's going to make the payment. So those are all what we call data-driven, right, predictive analytics. And sometimes it needn't be prediction based on the past. We may want to just find patterns in the data. That is called discovery. So think about is there anything, if you see a lot of non-payment behavior in a particular region in the United States, you layer that data with additional data about the economics and so on, and say, so we do discovery. So though both predictions and discovery is part of this, what we call statistical analysis of data, that's machine learning, and machine learning is front and center in data science. But it's just not enough in machine learning, understanding the patterns. We still, human beings, we plan, we schedule our operations. Think about self-driving cars. In self-driving cars, you have a pattern recognition system which says where the lane markings are and where the images are, right? Where the stop signs are. But still, there is a decision-making logic that says, I need to stop when I see the stop sign, or there is a red, the signal turn. So those are what we call higher level of thinking, reasoning, which is to do with the planning and scheduling. And that forms part of AI. And then the cognitive computing is the entire scope of how our neural networks, just like our neural networks help us dream and plan and so on, can we actually come up with computational neural networks that will allow us to understand our risk-taking behavior and so on. So all that goes into AI, and therefore when you hear data science and AI, think about data science is a subset, but it has taken a life of its own as a separate discipline. Okay, so examples are abundant. You're experiencing every time you use your phone to, use your face to open your mobile phones, their face recognition at work, and then you hear of lots of self-driving cars. That's going to be that's one of the biggest development that is predicted to become part of our lives in the next few years. Self-driving cars, and self-driving cars is replete with the AI, right? Where there's pattern recognition going on, image processing, there is reasoning, there is scheduling, complex AI reason. AI is embedded in self-driving cars. And of course, in healthcare, you might have heard of IBM Watson for oncology, where images, right? Mammograms to other MRI to other image data are being used to analyze and diagnose potential risk of cancers. And therefore now AI is augmenting and in fact sometimes expanding human intelligence. Wherever there is humongous scale and there is data that we need to look at in order to make a decision, AI comes to our rescue. Next page, please. This is a quick example of where, where you're seeing this, this is unfolded. This has now part of our pretty much daily life is where the customer experience has been completely reimagined with AI, right? So we not only use, we experience Alexa, we use Siri. Think about that. Siri is doing speech recognition. Alexa is doing speech recognition, right? It's taking the speech signal and converting into coherent text, which is now analyzed by a backend engine in order to provide the answers to the questions we ask. So what we are seeing is a continuum of AI support, AI assistance, providing useful functions to enhance our experience in whether we are dealing with banks or whether we are dealing with mortgage lenders or whether we are dealing with other healthcare companies too. In everywhere, I can't go past a single website today without a chatbot coming up and saying, how can I help you? So you have that continuum of chatbots from what we call FAQ assistance, where they're answering specifically programmed questions. There's only a fixed categories of information that they can provide, to chatbots assisting the agents who are fielding calls. Still, in many industries, human beings are staffing the contact centers because of a variety of reasons, sensitivity of the data and so on. And I built one actually for several clients where the agents often may not, have the answers immediately because whether they are new to the job or things are changing rapidly. For example, think about mortgage interest rates are changing. So one has to remember that interest rate daily. So we actually built chatbots which can be very easily assisting the human agents to have a much better experience and answers, rapidly. And then you have this whole Google AI, Duplex, and Cortana, lots of different kinds of chatbots, embedded devices with voice recognition, helping the customers. And at the end of it, is as the continuum goes on, we have seen what we call open dialogue. So our chatbots are not just talking about helping the customers with certain topics, but anything open, which requires deep learning and neural natural language processing and so on. So that's the ultimate experience where one can chat with the chatbot as though it's your advisor, it's your companion. It becomes a true companion. Next slide, please. Over to you, Sujal, and I'll add.
Yes. So this slide actually talks about all the roles and kind of career progression that we can actually go ahead on the lines of data science and AI. Okay, both separate, as Chitra already pointed out. So Chitra, what I would probably ask a question here. So from a career opportunity perspective, right? Like if somebody is looking at AI, right? What are the specific path they can follow, right? And if they are not related to data today, like maybe someone who has been into, say, banking or banking, a teller in a bank, or maybe a business analyst who just puts the business requirement document together, or a project manager for that instance, maybe related to AI projects he can go in. But what would be the career opportunities for someone who doesn't have any experience around data as of now? That's one. And what would be the approach that he or she should take in terms of being successful to reach the first step in and around data science and AI, either of it?
Okay, so I believe there are two paths, right? So one is the formal AI, like I went that route, where, right, I've had, from undergraduate, my undergraduate degree to master's to PhD, there is a continuous thread of my passion in understanding how the brain works. And therefore, I've been working with neural networks for the longest time, and computer vision and so on. That's a very formal path where we have a structured curriculum that I went through, and people, research scientists like me, had gone through and went on to build on that. There is that path, right? The formal scientist career. To data science actually allows itself to have this the non-formal path, where one could have been a teller in a bank, one could have been a hospital administrator, one could have worked in procurement. Regardless, they can actually move to, if they so desire, move to becoming taking this pathway to data science, right? Ultimately, at the end of the day, regardless of the role one was, data requires a basic foundational element of curiosity and a healthy skepticism. Am I seeing this for real? So curiosity, what is in the data? And then having seen what is in the data, a good amount of disbelief that, am I seeing the right things in the data, right? That's again patterns. So therefore, making the transition to data science as a on ramp to eventually getting to become a data scientist is one very doable. So you start with bringing your natural curiosity and what I call data, being a data hound, into data, looking at data more closely. So you start with this data curation, which is a boot camp we are running, wherein we are developing this skill set to be comfortable with data and around data, and the ability to manipulate data comfortably, and the ability to visualize and present the findings in the data. So you can see, therefore, data curation, data architect, data analyst. I would say data curation and data analyst are very good starting steps to assuming the more sophistication that comes along when you're becoming a machine learning and so on. So I would start with data curation and data analyst, and then pick up skills with programming with data, right? Which is the data engineering. So now you are transforming the data that you have into many different ways using programs. And then it goes on. So looking at the picture, you're going through counterclockwise: data architect to analyze, right? Data analyst to engineer to machine learning algorithms. There, once you hit the machine learning engineer level, one has to be comfortable around statistics, because many of the machine learning techniques are founded on statistics, and therefore one has to have, if not a formal immersion in statistics, at least a level of comfort, right? Going beyond, I would say, high school statistics. Knowing the foundations of statistics would be a long way. In order to applying existing programs is not, we are living in a world where the software, one doesn't even have to write the software. But what I find when you don't have a good sense of good foundations in statistics is missing the interpretation, or being inclined to make wrong interpretation. And so machine learning would be the next role, and data scientist, where you're not only applying the algorithms that exist today, but also to design new algorithms, new ways of looking at data, combining the audio and the video, the images and the text in a robust way that you can make good decisions. You can infer good insights. Over to you, Sujal.
Okay. Yeah. So the next question I have is, like, as we got to know that, the prerequisite is to understand the basic of statistics, right? With that, like, do we have any specific certification? Like, if you want to be a cloud engineer, you have certifications available. You can go through a specific curriculum that is available openly on, the way you search it. You can reach out to companies like PamTen, get yourself trained around those. So likewise, do we have any specific path that people should look at and follow to become an AI engineer? The non-formal way. The formal way, you already answered that, right? So it's already designed. It is, it will build that discipline into you. But if you are getting on from a very different industry and a completely different environment, how do you cope up? And what are the specific certifications or those, feathers that you can collect onto your hat so that it can add value to your career?
Yeah, what I see is two trends emerging, and some of them are really good. One, I would say, one is the comfort and knowledge of applications of techniques, right? Machine learning techniques. There is that. And then second is really working with real world data. That is, I think when people like me or other companies, they are looking to hire, whether it is data curator to data engineers to machine learning, in order for us to assess whether somebody is industry ready, right? It takes two things, I would say. One is knowledge of the various machine learning techniques and when to apply them. When do you apply logistic regression as opposed to linear regression? When do you apply deep learning techniques? And what kinds of data are best suited for that? Right. So knowing, you don't have to implement a logistic regression or even, go into the mathematics of the logistic regression, but understanding that here is a toolkit, right? Toolkit full of how you build a predictive analytic algorithm. How do you apply these mathematical techniques, machine learning techniques, is very important. There's amazing stuff available in Coursera, Udemy. I see highly reviewed and recommended courses are available, well put together, one of the reputed professors at Stanford. He's very well known for some of his Andrew Neg. He's very well known for some of his courses available on Coursera. So likewise, I would say AI also. So even though one may not go through the formal curriculum at universities, one needs to know, develop in. So how do you build your own toolkit? And which tools are you most comfortable with? We may not all be a general purpose contractor. We may want to specialize in numerical data analysis. One might just say, I love working with data. I love using techniques that are available in Python and other techniques, other deep learning techniques to assess, look at images. And what is in the images, because they all go into self-driving cars. And then someone will say, I love understanding speech, because what's in speech can be turned into text and text can be analyzed. So we all can pick up our own specialization, but you need to know the right kind of tool set, right? So that is what you want to go look at, or any courses available. At the end of my doing the course, what am I going to know? What tools will I have in my toolkit? And secondly, so that is the first one. Second thing I would emphasize is gaining experience with real world data. People come and tell me, they have done this, and I say, okay, what kind of? Oh, I took 100,000 rows and so on. We are rife with data. There's so much data around us, Kaggle and then government data, Bureau of Labor Statistics, Federal Reserve. Everywhere, government, in the United States, there's so much access to data, and even Google has a data sets search also available, which is just fantastic. When I did my PhD, I'll tell you, it took me 3 months to set up an experiment. If I missed anything, the lighting went wrong during my experiment, capturing the images for my PhD, I'll have to start all over again. And now the data is right there. So practice your knowledge of the tools on real world data sets. Reddit has tons of text data, right? And Kaggle puts out all the time competitions, these data science competition. So that's what, when I'm looking at resumes and when I'm understanding the level of depth of understanding, this is what I'll be poking at. Okay, what kind of data sets have you played with? Have you experimented with? How comfortable? What stood out to you, right? In the data set. So I would recommend approaching learning to be a practitioner. We are talking about practitioner, right? Not one of research scientist, but being a practitioner in data science requires both toolkit, tool set, your own tool, tool belt, as well as experience with, real world data sets.
Yeah, I get your point. So basically, it's more about, eye for detail is definitely important as you put together a data, right? As a statistician, how would you look at it? Like how you dissect and bisect the data, and that has to make sense. Like the smallest form of data that is available should make sense, right? So now, probably out of context, but as most of the people would be spending time, as you brought up, that we can get the data accesses from various government websites and stuff. So what would be your thought process of using the regression algorithms and recommendation algorithms and all that are already available, right? Like most of the cases, we don't need to really look at it. There are customization that is needed, but we really don't need to build it from scratch in most of the cases, right? Because you have GitHub, you have various other portals from where you can get those ready-made algorithms, right? So how is that, is it a value add to try modifying and customizing it to your interest, or else spend more time figuring out the exact match of algorithm that can be utilized?
I see. Good. Yeah. Believe it or not, some of you may know in clustering, which is called unsupervised learning and clustering. When I was in PhD, I had to write that K nearest neighbor. There's no, immediate package that you had to. So think about that. How far along? I think 3 things have tremendously made our learning or becoming good at data science easier. One is this tremendous availability of data, rich data sets. Secondly, the availability of techniques. One does not have to start from scratch. That saves, right, immense amounts of time, rather than building the entire algorithm and then debugging and then applying that algorithm on data. You have it, right, whether it's your favorite language is Python, or you're writing it in R, or you're simply, using APIs that are available. A lot of AI platforms are there, Google to Azure to Amazon machine learning platforms are there, where you can simply call their APIs to do the task that you wish to do. So having said that, to go to Sujal's question, where do you, one thing that should never be underestimated is retraining the technique algorithm that you have access to on your data. Because when people put out these packages, they have done their work on, let's say, bank data, right? They have done, let's say, some text analysis. I'm looking at, text summarization techniques, the cutting edge research in text summarization. If somebody were to, vent at, I'm in healthcare, I'm studying old people, and they are saying something for, 1.5 pages long, how do you summarize it into what is the essence of that, what they said? So that is summarization, right? Human beings, when I listen to Sujal may describe what he's looking for 2 minutes or 3 minutes, but I can exactly go to the heart of what he's looking for. So how do you embed that capability into AI is my recent research. So when I'm evaluating techniques, you will find those, Google's text summarization may have been trained on Google News, right? But that is not my domain. My domain is real people talking about their dementia problems. So you see immediately, just because the technique is available and Google has made it available, it's going to work immediately well. So therefore, that fit I was talking to you about, looking at the algorithm, understanding not the innards of the algorithm, what mathematical function went into it and so on, but more so, where was it trained and what was the results, on what large sets were they trained, and say, okay, how much will that algorithm work on my data? How similar is my data to the data the algorithm was trained on? That's where most of the problems arise. You hear in newspapers again and again how AI is biased, AI made a mistake, right? But it's to do with understanding, or rather not having understood the mismatch in data, right? And how data could be skewed and so on. So therefore, the data you're working with, you really need to have that, data hound capabilities. Looking at data and saying, is my data biased? Does it have only women or only men or only 18 to 29? And can I make inferences? Can I generalize it to the general population, or can I just only make very specific inferences? So therefore, having that deeper understanding of the data you're working on, and making sure that when you're using these techniques that are available, whether you can apply those techniques on your data, right? That's where there are people talk about the data bias, algorithmic bias, and the human bias. The data bias comes from the distribution of information in the data. Like, is it only gender specific, age specific, region specific? You can look at the data in so many ways and assess whether it is well balanced or not. The algorithmic bias comes in this way. The algorithm has been trained and built on certain things. You don't immediately bring it and slap it on some other data and say, voila, I am done. Voila, your inferences will be wrong too. So Sujal, that's where one has to be very careful. I worry, right, as I see people coming out and claiming they are data scientists, they are doing that. My usual, probing is, do they really understand how to look at data very rigorously? Mm-hmm. Do they have a nose for it? You don't need to know a lot of huge amounts of statistics, but one needs to have that data sense, looking at it and saying, I look at this is all too slanted, too biased, right? That's why now you see that we are in the world of rife with misinformation, because people are not too gullible. People are not being skeptical about. Anyway, good. I think we are getting some cues. Yeah, back to you, Sujal.
Okay, cool. Thanks, Chitra, for answer to that. And like with my experience, also I will say that that's the same thing, because like I have worked in the organizations wherein they expect that a server failure can be predicted on the basis of last 3 years data, which is absurd, because the server has to fail. It will fail, but you cannot say that it failed 3 years ago, it will again fail after 3 years. So you have a lot of other areas that you have to look at, right? So I agree with your point. So let's go to the next slide, wherein we talk more about how do we stand out, right? So it's all about, like, in last 1 hour, we have been trying to understand what the industry is about, right? And what is the specific skill that we require. We already know that there are some prereqs like statistics and basic mathematics and inquisite or curiosity that is required, right? But to get ready for the industry is working on real data, right? Just building something up and then creating 1,000 rows with Python codes itself will not add value. You have to look at the real-time data or the real industry data, and then see that what was the outcome there. Like, say today, COVID data is available. So if you are working on learning things, use today's prediction or try predicting it and see whether you are correct out of 7 days, right? So that's where you will get yourself right, and you will be sharper in your thought process. And then as you get sharper, you are ready for your role. That would be a roller coaster ride with data, right? So let's move to the next slide. Okay, so here, as we say that, we need the right skill development that involves 4 key pillars. One is research, like we definitely need to research what we need to learn, what are the areas that we have to explore, and have to have the curiosity to learn the latest and greatest in that particular area that we decide, right? And then demand analysis, that's where we come into picture, and we have already provided you the list of high demand jobs. And as we talk about jobs, we also talk about the core skills that is required, and we have custom curriculums also available that can be utilized to skill you on the same lines, like may it be today we are discussing about AI. Previously we have discussed on cloud computing, and we have more webinars that are on track for those top 10 career that we have for 2022. Let's move to the next slide, right? And this is more about what is available on the free net, right? So you go to internet, you have YouTube, you go Google, you get hundreds of and thousands of courses that is available, and they are very generic. That's one, and they're generous because it is free, right? So generous and generic, but does it actually meet the exact technology requirement? Not necessarily, right? If you want to learn the basic and how it works, it might be useful, but if you want to implement, it would not be the right approach, right? Then comes in the paid content that talks about Udemy, Coursera, and LinkedIn, right? They are kind of minimalistic in terms of cost. However, your hands-on experiences are limited. Your industry case studies are limited, right? And that's when PamTen comes into picture, right? So what we provide is we provide you the training. We not just take care of your generic knowledge, but we take it to the next level of the hardcore technology and auxiliary training that are related to that particular area. So if you say AI, we would definitely have a touch point on how data science and AI are related, how these curriculums would be working hand in hand, and then how cloud technologies also work together. Because if you are working on Azure and tomorrow you have to work on AWS, how that would be relating together. So that's how you become industry ready, and then we provide you real-time projects so that you get project ready also. And when you get to a real issue or a real scenario of a job, you have an instant solution that is available that comes to your mind, not ready in hand, but into your mind that you can implement. So that's all we have got for today, and we open up for question and answer if you have any.
So I just saw one question earlier, and it's a basic question about how is data mined? So is that something one of you would like to answer? How is data mined?
So Chitra, you want to take
yeah,
it?
Sure. Yeah. So mining is a colloquially used term, right? Just like you're mining for oil, natural resource underground. So now think of you have these mounds of data and you're working your way into it in order to find that golden nugget, which tells, okay, Chitra, having bought this book in Amazon, is likely to buy this book also, right? Or this other things also. So that ultimately translates into dollars. So that's what mining is about. So everything we talked about, right, which is curating as an important aspect of curating, analyzing, visualizing, all those go into mining. When people say data mining, it is, it's all the operations we talked about. So.
Okay, great. All right. Well, I know that we are a little over our 1 hour. So Chitra, thank you so much for joining us today as our guest presenter. And Sujal, as always, thank you for being part of this series. Just wanted to let people know that we have 2 upcoming events. Our next event in this series is going to be on June 8th. And it's all about data analytics graduate. So we're going to be covering Tableau, Power BI, and Click on that session. Our other event, which Chitra had mentioned, is being sponsored by SheTech. It is a data curator boot camp, which is also going to be starting in June. If you're interested in learning more about either of these things, you will be getting information will be sent by Joanne to all attendees, and you could respond back and we'll get you information and get you signed up. So with that, just want to thank everyone for joining, and we'll see you next time. Thank you.
Thank you, Elaine. Bye, everyone.